I remember a conversation we had a few years ago about windmills, actually. Do you remember that one? When we were talking about the efficiency of windmills.
I don't necessarily remember the conversation, but I can make a decent guess about what it was about.
Okay, because what I do remember, I think it was in your first year of college in one of your courses, you were talking about the maximum efficiency of a windmill, because air velocity has a certain momentum, but also an energy level. And what percentage of that can you transfer to electricity? Do you remember that?
Yes, that was actually in my second year, and that exact same course I'm taking now again. So, yeah.
So it's fresh in your memory.
Well, actually, the lecture about wind energy will be in, I think, 1 or 2 weeks. But I did look through the slides, and I did see actually the derivation of the maximum efficiency of a windmill.
I do remember you explaining it to me, but I don't remember the explanation. But it makes sense. I can remember that, because if you would stop all the wind and take all the energy, all the kinetic energy into electrical energy, then you would stop the wind, and there is no way for the wind to flow.
Yeah.
So there is a maximum efficiency, and that can't be 100%, right?
No, indeed. And of course, you also still have the efficiency loss in the generator itself that converts like mechanical energy to electrical energy.
There is a scientific upper bound to that as well.
Let me see, because I'm trying to find the slides, what exact number it is. And you get a very nice formula that's quadratic, I think, and it has a maximum...
Quadratic depending on flow velocity?
Let's see. It's well, I do have the power for, the simplified formula for the power output of a wind turbine is dependent on, let's see, the density of the fluid. So in this case, air, the surface area of the blades, and that is the swept area of the blades. So not just like the surface area itself, if you see what I mean.
Okay.
And the velocity of the wind cubed.
Cubed?
Yeah.
Okay.
And that is, and we'll dive into that a little bit more during my part. That is the reason, or part of the reason, why wind turbines need to be built up higher, because the power output is going as the velocity cubed.
Yeah, that makes sense. If the velocity is higher, then your cost-benefit ratio will just increase when you make the tower higher, right?
Yeah. And let's see, so the maximum coefficient of performance, or basically efficiency, is 59%.
That's not too bad. It's better than the solar energy conversion rate we talked about last week.
Mm-hmm. Yeah, that was more about 40%, I believe.
Yeah, it was something like that. So that's a 10% increase. Interesting.
20, actually, yeah.
Wow.
So a small editorial here, because this maximum coefficient of performance is indeed 60%, and it is like the maximum extractable power divided by like the power that is in the wind with a certain speed, u. And this maximum coefficient of performance is like a result of the so-called Betz limit. If you would like to see the derivation, Ollie will provide you with some slides that I was referring to. And also the efficiency of the wind turbine itself is actually lower, because this coefficient doesn't include the efficiency of the generator and other like mechanical losses that are in the turbine. So then actually you would have more of an efficiency like 40% if you consider the total system. Yeah, so wind turbines is of course not exactly the same as windmills.
No, of course not. Wind turbines are more focused towards producing energy and generating energy, while windmills are actually way, way older than that.
Right, but
even windmills are not the first invention, of course. Like always, I'm googling about an invention, and then you stumble upon some inventions that came before the use of today windmills.
Ah, okay.
The most obvious one is, of course, the harvesting of wind energy, and you can think really, really basic. Wind-propelled boats.
Right.
A sailboat is actually sort of a windmill. It doesn't rotate; it just moves forward. But it's a basic concept, if you know what I mean. They were first introduced a few thousand years before Christ. It's first introduced on the River Nile, probably. Well, you never really know, but we have evidence that it's been used around 5,000, 6,000 years ago in Egypt, which is one of the first uses for wind energy.
Okay, I guess that makes sense. I mean, you don't want to start rowing all the way down the Nile, so why not try and harvest the wind power?
If it's free and you can use it, it's a good invention.
Right, and you can, like the people that would be rowing, you can just put them to better use otherwise.
That's also true, indeed. Another thing that was around that time, it differs 2,000 years, I think. It's in the Babylonian Empire, a emperor named Hammurabi. It's a difficult name. In the 17th century BC, he wanted to use wind power for his irrigation projects. The Wikipedia page states he wanted to do it or he planned to do it, but I could not find a real source whether he actually did it.
So what was the idea?
Well, that is very hard to find actually, but what I think they wanted to do is use a windmill type of design to create a flow towards, well, what they wanted to irrigate.
So like a water mill.
Yeah, I guess you could say that. How it specifically works, I have no clue. But it is cool that, well, how many years is it? 3,700 years ago, they were already thinking about that. I think that's mind-boggling.
Yeah, and you would say that they would have the tools to actually do that, because if you see what kind of machinery the Egyptians used, that's already pretty advanced. So
yeah, but I think that's not that long ago.
Yeah, okay, that's 1,000 years later. But if we're talking 2,000 or 3,000 years ago, well, okay,
what's the difference, you know?
you would say that technology is advancing faster, but if you start to think about, okay, we're living in the 2000s, go back 1,000 years, I mean, what did they have? And if you go then back from 1,000 years to year zero, it's kind of weird to imagine how technology evolved during that time period. But okay, I see what you mean.
Most of the engineering development around that time was actually more war-based, like the trebuchet, catapults, and all those things. They invented iron, if I remember correctly, just to kill people. That was more or less all they thought about.
Now, I think times didn't change in that regard. People invent something and they put it to use in a war zone, but that doesn't necessarily mean that things were invented merely for or as war machines.
Except for windmills, I guess.
Yeah.
Yeah, well, I couldn't find anything that was war-related, but maybe I forgot about that. I wonder now. Anyway, I was wondering as well whether Hammurabi was using his irrigation system to irrigate the Hanging Gardens of Babylon, one of the 7 world wonders. Yeah.
Yes.
I couldn't find any real source, but I'm most certain it was not, since the Hanging Gardens of Babylon were made 1,000 years later.
Okay, yeah, that can be. Unless that particular person was already thinking ahead and maybe wanted to build the Gardens of Babylon, but couldn't do it for another 1,000 years.
Do you think those plans were already that old?
Possibly. I mean, you can dream, but you don't always have the means to build something you would want to. For example, the pyramids. Before the pyramids of Giza were built, the Egyptians had to make like 3 or 4 prototypes, which took them, I think, a good couple 100 years to finish before they actually could make that one big pyramid.
Let me see. I have looked into this some time ago. You're right that the Pyramid of Giza is not the first pyramid. Let me see. Wikipedia, please. I'm just looking for an outline, but it doesn't really give me what I want.
I don't think you should be looking for the pyramids of Giza though. Or you want to know how long it took to build them?
As well, but I also wanted to know how many pyramids that they built before they made the Pyramid of Giza.
There is a comparison of approximate profiles of the Great Pyramid of Giza and other pyramids, and it also shows when they were built.
Oh, right, indeed.
Although I'm not entirely sure if all pyramids or all structures are pyramids and built in Egypt, but...
No, they are not. There is actually one pyramid in the Netherlands.
Oh?
Yeah, it's not that famous. It's the Pyramid of Austerlitz. That sounds German.
Austerlitz. Oh, yeah, but that's built in during the World War, isn't it? Oh, no.
No, 1894. Quite recent, but still. And before the Egyptians, I think it was in Peru.
Like the Incas?
Yeah, I think those.
Looks like it.
Yeah, but those were like step pyramids. I think that's the correct word. Not like smooth ones, but like really, really high steps.
Mm-hmm.
How did we come to pyramids? I can't remember.
And, yeah, like advancements of engineering and...
Right. Another advancement of engineering was to make a nice bridge. It was one engineer, his name was Heron of Alexandria, also from Egypt, which also makes a nice bridge, coincidentally.
Okay.
He lived in the 1st century AD. What he did, actually quite cool, is he was, I think, the first to use a wind-driven wheel to power a machine. So he had, mastered mechanical engineering, you could say.
Yeah.
Used different mechanical elements to create a rotating and moving machine.
So did you know what it was used for?
Ooh, good question.
Or like what it did?
Let me see. Of course. It's quite classic. It's an organ.
Oh, an organ?
Yeah, like the music instrument.
Wait, when were we talking? Like what time frame?
The 1st century AD.
They had organs then?
Yeah, I guess so.
Okay.
Let me send you a picture of the way he built that one.
Okay.
It looks so interesting, right?
Yeah, it looks actually pretty, for like 1 AD, it looks pretty advanced.
Yeah, I would say that as well. It's something like a flute, you could say, but the wind is wind driven.
Yeah, so it's like a rotor is capturing the wind, and that is driving a piston, it seems. And that is like pushing air through the flutes.
Yeah, and if you could close all the flutes except for a few, then you could make music.
Yeah.
I think that's one of the most early concepts then.
This must be the first organ, I think, yeah.
Huh. If that's the definition of an organ, then yeah, it is. Awesome, right?
Yeah, I mean, It's. I think an organ really isn't anything more than just controlled sending wind through pipes. So
it's just an engineered version of a flute, you say?
Well, yeah, it is.
Awesome. I was reading a few pages online on the history of windmills, and one thing I came across quite often was 200 years before Christ. A few simple windmills in China were constructed for irrigation and pumping of water. But the weird thing is that every website that cited this part used the exact same wording. Like they just copied it from each other. And I couldn't find a real source.
That's suspicious.
Yeah, it is. It is. Because one thing I did find, for example, on the Wikipedia page, is the first practical windmills were used in the city of Sistan, which is in Iran, close to Afghanistan. And because of the invention over there, they started to move eastwards to China. That is exactly what the Wikipedia page says. So it's quite suspicious if you would say that 1,000 years before that they were already developed in China. Because in Sistan, Iran, that development was in the 9th or, well, maybe the 7th century AD. So that's quite modern. And it's,
right.
Well, it's very hard to believe that 2 centuries BC, they were already used in China, right?
Yeah, that doesn't really line up like that. Okay.
No, it's one weird thing I came across. But when you Google about the evolution of windmills, you come across quite some weird things, actually. Have you ever heard of prayer wheels?
No.
Well, I haven't had that one either till this afternoon, actually.
Oh, yeah, I've seen those.
What they did was like cylinders, which turned around because of the wind. And when you touch the prayer wheels, they help to alleviate the negative karma of those who touch it.
Yeah, so those are used in like Asia, right? Or in India, I think.
In India, exactly.
Yeah.
Yeah, like at 300 or 400 AD.
So yeah, it's a very broad definition of windmill, of course. But like you said in the beginning of the episode, I feel like as long as you're harvesting the power of the wind in order to get something done, then I would include it right here. So
okay, then we can agree on that. One thing I come across quite often actually when researching this is talking about toys. I already said it when I was talking about airplanes, but also about cars. And I'm gonna send you a GIF right now. It's called an Automa. It's a toy. It looks quite cool. It's a wind-driven toy. This one is quite modern actually, but the principle still remains the same. What do you think?
Well, I'm thinking two things. Of course, if we're talking about wind and harvesting the power of wind, then kites is something we already discussed last episode.
We did.
Although kites are gonna make a comeback in my part for a little bit.
Really?
Yeah. And the second thing I was thinking is how is wind, or what's the use of wind here?
I think, but it's hard to see in this GIF that the box on the just below the GIF is like a wind tunnel, which generates the velocity.
Ah, okay.
Okay, but I'm not certain how they did that. Of course, windmills can be used for very many practical things as well, like harvesting food. One thing they mainly did in the Persian Empire or in the Middle East is to grind grain made by using windmills, and that's one thing you come across quite often. Now I'm going to talk about like something 200 years ago when the Europeans started to go to the New World, like America, what do you call?
Mm-hmm.
They also use windmills to grind wheat and corn, to pump water is of course also a main usage.
But wait, when did they first start using this to make grain?
Oh, like a long time ago. I think it was 5th century.
Okay.
I do not have it right over here.
Because being the ignorant Dutchman that I am, I thought that like the windmills that we have to make grain was more like 1500s or 1600s.
11th century actually.
Okay. Huh.
Yeah, I just wanted to mention that because the Dutch didn't use windmills that much for food production, while the rest of the world actually did. And that is why Dutch windmills are, well, famous between quotes, I think, because the Dutch use them for the draining of lakes, of marshes, and polders,
right,
which are famous over here. And so what they did was, when you've got a wetland, you cannot build on it, you cannot live on that place. But if you can pump all the water out of it and can keep doing that, you can create like an artificial island. Flevoland, one of the 12 provinces in the Netherlands, Flevoland actually, is one big artificial island.
Right.
By just pumping out all the water using those windmills.
But wait, when they made the Flevopolder in like the early 20th century, I presume they didn't use windmills, right?
No, but they did use a similar technique.
Ah, okay.
It just wasn't wind powered, but the creation of polders started with windmills, which is really interesting in my opinion.
Also, going back a little bit is when you said so. Apparently, the Dutch didn't quite use windmills for food purposes. Do you know why that is?
Oh, I think because that was not the main problem we had.
So we could just import food, maybe.
I wouldn't know. I'm not an historian. Actually.
Yeah, no, that's fine. But I could imagine that since coming out of the golden century, is that the correct word?
Yeah, 16th century.
The golden age. So
yeah,
I mean, I can imagine coming out from the golden age that the Dutch were so rich that they could just import a whole lot of stuff.
I'm not sure whether they did that or not. Maybe they had specific windmills to produce food, but it's not the reason why windmills are famous in the Netherlands.
Yeah, okay.
Because in America, between 1850 and 1900, they built like 6 million windmills over there.
Wow.
Yeah, definitely a whole lot more than we have in Holland. But the way they were used is the big difference for what made them famous and what did not.
Oh yeah, I mean in America, I reckon you don't quite need windmills to move water from one side to the other. So yeah, that makes sense.
No. Most of the land is above sea level anyway.
Right.
So that made the use of it different actually. One use they wanted to implement, which was in 1887, was of course electric power. Before 1887, everything they did was sort of mechanical engineering. They started to get things in motion, but you could also do that with water mills. But James Blyth from Glasgow was the first to try to make a electric powered windmill, or a windmill that can create electric power. Actually, the order is quite important, of course. I've got a nice picture over here.
Those were probably pretty small then.
Because this is quite recent, you already had the daguerreotype we spoke about earlier. This is how it looked. Doesn't it look great?
Nice, yeah. So it's almost like an inverted like water scoop, but then for air.
Yeah, what is different about this thing is when you think about a windmill, the rotational axis is horizontal, but these early windmills were actually with a vertical axis. So that made it different, actually.
There are some types of wind turbines that still use a vertical axis, but they're just not very commonly used anymore.
No, it's probably it probably has to do with the efficiency, I guess. Anyway, James Blyth was quite proud of his invention, I guess. He was actually used to light a cottage with it, his house, I guess. So that was the first house electrically supplied with power generated by the wind. Also makes it quite interesting fact. But he was really proud of it. So he tried to sell it to a city nearby. Marykirk was the city, but he did not succeed. It's not because of his marketing skills, I guess, but the city thought electricity is the work of the devil.
Oh.
Yeah, so don't touch that.
Oh, poor guy.
Yeah, poor guy. His invention never caught on because it seemed too expensive, or like I just said, people thought it was the work of the devil.
Oh, yeah.
1 year later, or actually not even a year later, there was a guy, Charles Brush, in the winter between 1887 and 1888. He made an other type of windmill. Let me send a picture to you. This one has actually a horizontal rotational axis. What do you think?
Okay, so that looks more like the windmill that we know.
Indeed. But look at the guy standing in the right bottom corner.
Right, it's huge, and that's something I wanted to comment about still on the other picture as well, the earlier one. That's also still relatively big.
It is, but because the efficiency was like really, really low, they had to have like massive windmills. The one created by Charles Brush has a 17-meter diameter, is 18 meter high. Well, the rotational axis is placed 18 meters high, 144 blades, and was used to make a nice bridge to 2 episodes earlier to operate 100 incandescent light bulbs or to charge a bank of batteries. So that's 2 episodes linked to right now.
Yeah, so the number of blades is really baffling to me. I wonder... Well, it did work for that model, but yeah, it's not like more blades is better always.
No, you would think no, because modern windmills only have 2 or 3.
Right, yeah.
So you would say that's the optimum. Well, this one created 12 kilowatts of current.
Oh, that's not so bad.
A modern one does 2500, so that's like 200 times more.
Yeah,
but when you consider the invention of the electric windmill was only like 6 months old.
Yeah, but also, well, considering what was it again, 17 kilowatts? 12 kilowatts. The amount of electricity they used back then was relatively small. So considering that, it's still pretty good.
Oh, it is. But if you think about the potential increase of what they could do in only 120 years, that's quite insane. But indeed, like you say, 12 kilowatts it's still quite a lot. Windmills were actually not connected to the main power grid back then, because mainly throughout the 20th century, many small wind plants were built. Like I said, 6 million were built between 1850 and 1900, but they were mainly used if you lived off the grid. So just in the middle of nowhere, and you still wanted to have a bit of electricity, then the windmill was like the perfect solution for you.
Yeah, and I think that's a perfectly fine way to tackle this problem. And even considering back in those days where indeed people were so remote or far away from each other, it probably didn't make a whole lot of sense to make a big power grid.
I guess that's the reason too. But once the electric power grid was finished throughout, I don't know, a country, the use of windmills actually decreased quite rapidly because, windmills, like you can imagine if you look at the last picture, are quite expensive. And if you would compare that to burning oil or gas, it's ridiculously expensive. So they started to use the materials for other purposes, I guess.
Yeah.
And they just started burning gas.
Yeah, so from an economical standpoint, indeed, it does make a whole lot of sense to not use them. And like 200 years ago, the environmental impact was not a big issue at all. So
No. And they still had oil enough,
Right.
so why would they,
Huh.
In the USSR, modern Russia, they did have another idea, though. Let me send you a picture of that. This is going to be a bit more modern. It's made out of steel, like you see, and 30 meters high, 3-bladed, quite modern, as you would think. It's not as high as a modern one, but it already looks quite a lot like a modern windmill does. And that is a development which is really, really unique. It was a one of a kind, I think. Those developments were not like really important. They had, like I just said, oil enough. And they had other things to worry about, like America, I guess.
Yeah, that's interesting that they still like came up with this. And also, if you look at like the left hole going to the ground, I think that's there to prevent the whole thing from falling down, which is still a pretty big issue today. Although we have by now like found stronger materials, so it's not as much a problem anymore. But yeah, that's funny to see that.
Now I can imagine that all those forces make it quite necessary to have support in that direction as well.
Yeah, especially because they just made a grid of steel beams. So I suppose the structural integrity is not that big.
Well, a truss element like you see at the support is actually quite structural good, but I don't know, it was probably needed. The Americans, on the other hand, like 10 years later, built a similar tower. They did make a structure which looks a lot more like a modern one. This one has 2 blades actually, but it also has one vertical shaft, if that's correct. Not a truss design though. And like you see in those pictures, development starts to go towards what we think of a windmill right now. One thing that changed the development quite rapidly actually was in 1970 they noticed that their oil was running out
already.
It was before they found a large supply again. But when you do not have any oil, you need to have other developments to generate your electricity. So what did they use? Well, I guess you know the answer.
Wind power?
Yep. Well, they started to develop that. You wanted to have efficiency, so you wanted to have rotational devices, so you could get the optimal direction, if you know what I mean. And all those minor improvements. One thing that's quite modern actually. In 2009, the first deep water large capacity floating wind turbine was made.
Wait, what?
Yeah, I know, right? Deep water large capacity floating wind turbine.
Okay, that sounds good.
Yeah, it was built in the North Sea, in Norway, actually. And what I think is really interesting, it's a monopile. So it just has one foundation on one pile. And that's quite insane if you think about that as a civil engineer.
You mean one tower, like how they call it nowadays?
Indeed, one tower, but the support is normally multiple piles into the subsoil. This one was not. It was just one pile going straight down, creating all the support for the tower. Okay, what you would normally do is make a few diagonal supports as well, which make it quite easy to make sure for the structural integrity, like we saw in the Russian design from the USSR. It has a diagonal support which is good for the reaction forces. This one has not.
Okay, so how did they manage to get that?
Yeah, you just need to get a foundation like really deep into the soil, and it will have to bear like massive bending moments. But I think that is what they took into account. It has to be.
Yeah. So and that already saves up a lot of material compared to the Russian model.
It does. What's also very interesting, which we spoke about in the beginning of the episode, is like you said, wind speed is cubed in the equation for
power,
for how much energy you can create, how much power you can generate. Indeed, because they started building on sea, wind velocity just rapidly increases, which makes these things like really interesting. And the Japanese were thinking about that as well. In 2011, just after the tsunamis, they started a project to build 80 floating wind turbines, a project costing 10 to 20 billion yen, which is divided by 100, roughly $100 million,
okay,
$200 million, just to provide for the energy need in Japan. And that's also, as a civil engineer, that just amazes me, because you've got earthquakes with a magnitude of 7 over there. You've got tsunamis, typhoons, and all those things heavily degrading your soil and your structure, and you're gonna build windmills over there.
Well, they made floating windmills in front of the shore, right?
They did, I guess, but still, then it's
a risky undertaking, but you gotta get power from somewhere.
That's true. Well, it's amazing engineering.
Oh yeah, for sure.
And that's what I wanted to tell you.
That's something I wanted to talk about as well, is because especially Japan has an issue where, for example, here in the Netherlands, we can just build wind turbines offshore because the waters are not too deep in front of the coast. But in Japan,
now if you go into the North Sea like 100 meters. I think it's still like 1 or 2 meters depth.
Yeah, it's really shallow still. So that's why it's relatively easy to build wind turbines off the shore. But in Japan, the waters get way deeper, way quicker, and then it becomes increasingly expensive to make them.
Which makes a whole lot of sense, of course.
Yeah. So that's about the end then where you wanted to end, 2011? Which is actually pretty late.
Yeah, I wanted to end in 2011 indeed. Well, it's actually an ending in the year 2020, I guess, because those floating wind turbines are not built yet. They are doing that right now.
Okay.
So it's quite a modern project.
Yeah, that's like the first time I think you ended on a future note. So
probably. I gotta do that more often, I think.
Yeah, maybe. That's a pretty nice overlap, because what I wanted to start with is the question again, but what really is the problem we are facing right now with wind turbines? Because not everything is so nice as it first seems. Because from, a like renewable energy perspective, wind energy is readily available. It's everywhere. But still,
wind energy is not a problem, but the way you manufacture it is the problem, because all those steel elements do have a massive influence on the environment, right?
Yes, and that's one of the main issues, I would say, with these wind turbines, is it costs so much steel and concrete for like the foundation and the tower, And both of those resources have a very high environmental impact and also very high transportation costs, because it's not very easy to transport a tower of 90 meters long. And of course they transport it in segments, but even then it's very difficult.
Especially when you get it into the ocean, I guess. If you want to have that like in 20 meters deep ocean, that's gotta be a problem.
Mm-hmm. So a couple numbers. One of the newest wind turbines that's, I think, the highest, or at least one of the highest wind turbines, is the Enercon E126, and it weighs 6,000 tons altogether.
Okay, that's like 6 million kilograms or 12 million pounds.
Yeah,
right?
And that's including foundation.
Yeah, that's quite a lot.
Yeah, indeed a lot. And there are some newer models with wind turbines that do weigh a little bit less. But the problem is, if you want to harvest more power, you want to go up higher, because like we were saying earlier, wind speeds that are higher when you go higher, and are also more stable, because here at ground level, wind speed happens to fluctuate a lot, and the higher you go, the more stable it gets.
Oh, I did not know that. I just always assumed it was quite even.
Yeah, so you would indeed assume that wind speeds are rather constant and that they wouldn't change as much the higher you go. But there is a formula for wind speed, and it goes, let me see, it goes with like the square of the height, I think, or something like that.
Okay, so when you quadruple the altitude, then your wind speed multiplies with 2. That's about the conclusion.
Yeah, it's not complete. Well, it's not completely the square. I have trouble finding the formula that I was looking for. It depends. Okay, so it's like the the height to the power alpha, and alpha is like a coefficient that depends on the ground that you're above. So if it's like grassland, if it's water, and so on.
Okay, interesting. I did not know they could model that. I always assumed it was just empirical, and they just knew it.
Yeah, no. So these these coefficients are empirically determined, but even then, there is still a pretty nice power relation for wind speed.
Oh, interesting.
So yeah, for a long time, I think tower heights were at about 90 meters. That seemed to be about the maximum. But the Enercon that I was talking about earlier, that one already has a tower height of 130 meters, but it also does cost increasingly more material to get to more heights. So how are we gonna fix that?
Yeah, of course, it's not like really linear, because your weight gets more. But if you have a constant force on the top of your structure, then your bending moment will increase linear, which means you will need a way wider support.
Mm-hmm.
And the question is, of course, what's the most optimal height? If you want to optimize the power you generate, but you want to reduce, of course, the costs, the material costs it has.
Yeah, and I do have to say, though, I think that was one more newer model that was still a bit higher, but that did weigh less. So indeed, engineers are definitely finding methods to make towers that are either from stronger steel, so you need less material, or just other tower designs. But even then, it's a ridiculous amount of material you're using.
While I was researching the history, I came across this infographic. Let me show it to you. It is, as a function of time, the height of windmills and the power they could generate.
Ah, nice. Oh, that's
cool.
Yeah,
quite nice, actually, right?
Mm-hmm. Yeah,
in the 1980s, they were like 17 meters high, and now they are like you said, 130, if you have the massive ones.
Yeah, and one particular problem, by the way, as well, with making the blades bigger, is that the stress on the blades increases as well, because since the wind speed is a function of height, also that means that there is like a force gradient across the height of the tower. And you also have to account for that somehow on the rotor, I think. But that's also a problem, like the higher you go.
Yeah, I guess that makes sense. Especially the part that connects to the axis.
The rotor, yeah.
Yeah, massive forces will be over there. You've got the rotational force, or what's it called?
The torque.
That's not what I was thinking about. But also the wind velocities generate indeed massive forces and stresses into the material.
Yeah, and one last thing, but that's not a huge issue, is that it's not very aesthetically pleasing to have one of these massive steel constructions right in front of your doorstep. And this is even worse with offshore constructions, because people complain all the time about how it ruins their view when you place a wind park offshore.
Have you been to Katwijk, one of the Dutch cities, recently? I think they built a windmolen park like 10 kilometers offshore.
A wind park, yeah, or...
Well, you really have to try your best to see them.
Okay, that's nice.
It's impossible, actually. When it's night, you do see those flashing lights they put on top of the structures. Okay. But I'm not really sure what they are complaining about.
Well,
if you do build that on land, of course, I can imagine it's quite a massive structure, quite some noise actually as well.
Yeah, indeed, I didn't even consider the noise problem. But I suppose maybe the wind park in near Katwijk might be very far offshore, such that you hardly see it. But the problem with placing it farther offshore is also that your transportation costs are going through the roof. So I'm not sure how they managed to do that.
Well, if it's on a boat, I don't think it matters that much. But if you want to place it on the soil, it will be a problem, except for when you're building in the North Sea, because I think that's quite constant water depth.
Okay, so that might be the thing. But at least I know from a couple wind parks, or at least one, for example, near the shore of where my aunt lives. That's a bit farther up north. There they were complaining a lot about the view and so on. And indeed, if you go out there, you can plainly see the towers. Also, on another note, by the way, for some reason, offshore turbines can be even way higher. I saw one that was even 220 meters tall.
What?
Yeah, it's insane.
Why are those like way higher? I don't get that, because you could think that the efficiency as a function of height does not change compared to inland structures.
It's the one I was talking about is the Vestas V164, and it's a 9.5 megawatts turbine, which is like really high, because most turbines have been either 3 or 5, maybe a bit more, like the one you show in this infographic is 7.5 megawatts. But it seems like still engineers manage to get more and more power out of these things. By the way, the total height is 220 meters.
That's insane.
Yeah. And I'm not sure if this is like specifically because it's an offshore wind turbine that it is higher. I could imagine that maybe buying real estate on the shore is not as expensive as on land. So if like the tower base is bigger, it doesn't matter so much, maybe.
Oh, and what can also be a problem, especially in the Netherlands, is the soil is a bit too soft. So if you make a massive structure like that, I think it will subside like a whole lot. And that's something you don't want to. And you've got, of course, airplanes. Maybe that's a problem.
Also, yeah. So I can see how offshore turbines can be taller, maybe relatively easy, or at least, easier.
Yeah, that does make sense.
Okay, so that was the introduction. Now the question is, going forward, can we still keep going higher and bigger? And
the answer is...
Well, the answer is I'm not so sure. If I'm seeing these numbers, like 7.5 megawatts, 9 megawatts, I would say it definitely is possible. However, the question is also, is there a political will, a social will to keep making more and more wind turbines?
Yeah, engineers always say everything is possible. It will just cost a boatload.
Yeah, and that is why people have been starting to think about maybe options that are more cost efficient or more like environmentally friendly. One thing, for example, that struck me as very interesting was a model that was not so much different from what we have today. It's called the multi-rotor wind turbine. And if you look at it, it's basically just a wind turbine, but then with 4 rotors.
Do you know what that reminds me of?
No.
What this does remind me of is one thing I came across some time ago. It's built in England.
Wait, what? It's like a triple roundabout or quadruple roundabout.
It's the magic roundabout in Swindon, England, which you might have heard
Oh,
of.
that looks horrible.
Yeah, but I'm thinking the exact same about this windmill you just sent me. It's a windmill on top of a windmill.
Well-
It just looks weird.
Well, but this is like truly driver's hell. I would not like to drive here. But yeah, on a more serious note, you could wonder why in the world would you want 4 rotors? And a small disclaimer, this thing is not necessarily meant to go commercial, but it's more as a like proof of concept for like innovation. Or let me like read it in the words of I think the CEO of Vestas. While there is no guarantee for success or that we will end up with a commercial product, this process of continuous innovation and exploration is extremely important. It provides us with essential knowledge that can help us bring down the LCOE or levelized cost of energy and optimize the annual energy production of our products in the future, ultimately integrating key technologies to solve our customers' challenges. Right.
Okay, so the point is, so you can use one structure to create 4 wind turbines,
Yes.
and by that way you can make it more material friendly.
Yeah, and also, well, a big part is also this levelized cost of energy is basically a way to try to have a standardized way to say, okay, but how much does 1 kilowatt of this source cost? And that also includes transportation costs. And with this thing, you can optimize the transportation costs a little bit because with like relatively less transport, you can make 4 rotors or 4 wind turbines.
Yeah, it doesn't need that much materials, but it's hard to see what the relative sizes of those wind turbines compared to a regular one. For instance, the one compared to the one that's placed behind that one.
Yeah, I'm not entirely sure. So it's 74 meters high, but that's because they were limited to their test area, which they can't build higher than 74 meters. But in any case, I think the swept area by the 4 blades is still bigger than the 1 blade that's behind.
Oh yeah, right, definitely.
And so if you can...
But it also uses a lot more materials.
Well, you would say so, but compare... So say if you would make 4 rotors on 4 towers, then you would need 4 towers. Whereas for this one, you only need 1.
Yeah, right.
So
yeah, I can see the improvement by this design.
Yeah, but but even then, it seems kind of silly. It might work, but even then, it's only still a small deviation from the classic model that we have now. So people start to go ahead and think, okay, but can we maybe like completely move away from like towers and so on and do something completely different? Because the problem with these towers is that they cost so much material. And indeed, there is, for example, one thing here. Oh, let me grab the link. It is the Alteros BAT, or Buoyant Wind Turbine.
Okay, this is not a normal type of windmill. I already see that on the picture.
Yeah, so small disclaimer, the rest of the episode is not going to be about conventional windmills, but really about other ideas to harvest wind power and generate electricity.
I think that's a windmill as well.
Yeah, well, in this case it is, but other designs that might come up might not be anymore. Anyway, so this, it looks... The idea about this thing is pretty nice, right? We have a small wind turbine. We're gonna lift it up with basically a big helium balloon. And then
Yeah, it looks like a Zeppelin.
Yeah.
Actually.
It basically is a Zeppelin with a big hole inside.
Which does generate power.
Well, there is, if you like click on the link and see the picture, there is like a small turbine with a rotor inside with like 3 blades.
Oh, right, I see it now.
So the benefit of this would be no tower, which also means no ground used. So you can use that for other stuff. But there is, to me, a clear disadvantage. And that's like 2 things. One, the wind turbine is not very strong, so it doesn't provide that much power at all.
Okay.
And the other thing is that it's using helium.
Yeah, and I know helium is quite scarce, right?
Yeah, that's what I thought. I tried to look into this, but apparently there was like couple of years ago, scientists found a new reserve of helium or something, and everybody was happy because now helium is not scarce anymore. But still, it's like you use it, and if it goes away, you never get it back. So it will run out at some point.
Okay, well, if it's not that soon, then I think it's a better option than for instance, oil, which will run out quite quickly.
So this could, in that case, it is indeed really nice. And I gotta say, this product is more meant to provide energy to very remote areas, so where it's hard to build a big tower anyway, or to be used for, one example, when there is like a hurricane, there is a power outage, you just bring this thing to the area where has been a disaster, and then you have power.
Yeah, that's quite smart. Those are quite easily movable.
Mm-hmm. Yeah,
it's an interesting concept. Thanks for showing that.
And the very nice thing to me, and that's like the big plus side, is you can use this as a Wi-Fi hotspot. And since we were talking about remote areas, that will be a nice thing to like provide. And also can be doubling as a weather station, because you can tag on some instruments on that.
It's multifunctional.
Yeah.
It's a good combination. I gotta admit that.
So nice product, although it's not gonna help us solve the energy problem. So another like radical idea that to me is very interesting is the so-called sky sails, and this is an idea that I'm actually pretty excited about, because I feel like it's a very viable idea that can definitely help us like produce wind power on a larger scale. Now,
you would say that's back to the old-fashioned mode of transporting by boats.
Yeah, it kind of is, and that is the funny thing, because I think this idea started out for boats or for tankers, because they could tack on a sky sail, and then they could relieve some power from the main engines, and that way like save a bit of fuel.
It's actually a big sail ship.
Okay, so let me explain how this works. Otherwise, it's not that obvious how it works. So it's a kite on a big tether, and the kite is going in like a figure of 8. And as it goes farther up in the sky, the tether like rolls out, and that the tether is attached to a drum, and so that drum is basically rolling around. And that drum that's rolling around is connected to a power generator.
Okay, so it's not actually pulling a boat, it's used to generate power, which is pushing the boat.
Yes. So if you have like a hybrid engine, then this you can use this to power the engines.
That seems like a weird extra step, actually, right?
Well, but no, because if you have a hybrid engine, you can save a bit of fuel.
Yeah, okay, but why not use the kite to pull you forward?
Oh, then you would need a massive kite. That's like that. You can't do that.
Oh, okay.
Because I mean, do you know how big the sails were on an old like 17th century ship?
Yeah, probably quite large. But even in this way, you cannot provide that much power outside.
You would say so, but so I think the power figure that they're looking into is per sky sail is like 2 megawatts. So that's pretty considerate.
That's what a big windmill does.
Right. But I was not entirely ready yet, because you can wonder, okay, so this like tether extends, and at some point the tether length is maximized, and then what? Does the process then stop? So then what happens is, with an automized system, I'm not sure how it's called, but like where the tether is attached to something, and that system can find a track that is of the least resistance, and then gently pull the kite back in. And that like pulling the kite in doesn't cost so much power, because you do need a little bit of power to like pull it in. But with computer algorithms, they can calculate the position for the kite to minimize that energy. And then you start all over again.
So it's quite a few movements, but in the end you produce a bit of power, and that you put back to the engine of the ship.
Yeah, and
right?
so and if you want to make this a power generating machine, not for ships but off the shore, for example, you just tag it on a floating base or a floating platform, and then you can very easily generate power that way off the shore.
Oh, right.
And there are two big benefits to this. One, of course, is that you can go much farther offshore, because it's very easy to go to like anchor the platform to the ground, say up to 700 meters deep.
You could even use islands which are not used by civilizations.
Yeah, of course, although then you have to transport the energy back to the mainland. But going back to the example of Japan, this is actually a very viable idea for them, because like the waters just outside of the shore are pretty deep, but not so deep that this system can't be used.
Right.
And another big thing is that in any case, if there is a hurricane or a typhoon coming, they can just pull the sail in, or the kite, and then it can be like folded, and when the typhoon is over, then they can just deploy the kite again.
That's so useful.
Yeah, it's amazing, right?
Also, when you think about earthquake engineering, this is not a problem.
Right. So it's so universal. It's really cool.
Yeah, there's just one thing, that if the wind doesn't blow, then you don't have any power. But the same goes for every windmill.
Right. Yeah, and I mean, and in that case, okay, it doesn't produce so much power, but that is a nice thing. It is, of course, very easy to make a tether that's 800 meters long, and suddenly you're flying up 800 meters.
Oh, wow.
At which the wind speed, of course, is present, probably.
Yeah, the difference between the two is tensile forces, and tensile forces are way more easy to cooperate with.
Yeah, and the material cost is so low compared to the wind turbine.
Awesome.
Yeah, I'm really excited about this idea. I really think that this kind of system could definitely provide good power.
Is this being developed like seriously, or is it still in conceptual design?
I'm not entirely sure. I haven't really looked into what their next big plan is, or what the time frame is, or like if they have any projects, but I think this is still pretty actively developed, yeah.
It looks good. I'm checking out the pictures they have on their website. This episode is not sponsored, right?
No, it's not. And if you want to see a more fancy video, you can look this one up later on. That shows a bit more of like the system.
Oh, it doesn't work. It requires flash.
Yeah. Well, that's maybe you can find it on YouTube or anything. That's to me the system that has the most potential. One other thing that I came across, or two other things I came across, are less conventional, and well, I'm also not sure if they will be implemented or not. One thing is called the Deep Wind Project, and what that does is it's a floating wind turbine as well, but it uses a so-called Darius wind turbine.
Darius wind turbine.
I'm not sure if you ran across this, but this is a wind turbine that is a vertical axis wind turbine.
Oh yeah, right. I've seen these, but it looks weird.
Yeah.
How would you explain this in a word picture?
Well, so it kind of works the same as regular wind turbines. Really, the only difference is that like the axis is vertical, because you have like two blades which are wing shaped, and because the wind is flowing around them, you create a lift force, and that lift force is like can be used to let it turn around.
Okay, so it's actually like the first windmill we spoke about.
Yeah.
But this one used this lift, and that one used a cup actually.
Mm-hmm. Yeah. Well, I think because of the cup and of course the density of wind or the wind force, like the wind cups are not very efficient at all. And this at least is already a bit better design. However, the problem with these kind of wind turbines is that they need a little bit of power to get going. So yeah, that's a small disadvantage, but otherwise they still work. And the idea of this deep wind project is that basically they want to use a Darius wind turbine, but then like let it float offshore. And then the same principle applies again to any floating wind turbine. You can just tag it onto a generator and then move the power to the shore.
It does look like a cool design, but I wonder what the advantage is over a regular wind turbine. If you would use a floating system on sea, you face all the problems you would have using a regular wind turbine. This one is just a bit more fancy.
You would say so, but of course one big advantage is, again, less material used because, well, it is floating and the shaft doesn't need to be so big because like the torque forces are much smaller. Yeah, and I would say that that's the only benefit I can think of at the moment.
Yeah, if it saves material, which you can generate the same power, of course, it's a good development.
Yeah, and that's
but, compared to the previous idea you showed, this one is more fancy but less cool, I guess.
Yeah, I think so. And also it's not for example, I wonder really how these people are gonna deal with also when there is like tsunamis or anything, but maybe the same you can say for the previous project, but it seems a bit more fragile to me.
Yeah, I would say that as well. The blades do look like really thin.
Yeah, so I also couldn't really find so much about it, but still I did see it every now and then, so I tagged it onto the list.
That's a good thing you did that.
And then a last thing that actually caused some controversy, as in, okay, so this really is the most radical idea that we'll see today. It's not a windmill at all, but it's still harvesting the power of the wind. It's a bladeless wind turbine. Okay, that's...
what?
I see you thinking, and it's indeed kind of weird at first, but if you think about it, it's not so bad. So what the idea is...
Oh, wait, I think I know this principle.
Aha, okay, so what is... Does it remind you of anything?
Yeah, it does. It does remind me of this.
Oh, that's not what I was thinking about. Okay.
Okay, it's a different system then. Okay.
What is this?
It's like a sailboat, but instead of using a big screen to capture the wind, they use a rotating like cylinder, and because of, I don't know, physics, you could also capture the wind because of the way those cylinders like spin.
Ah, okay. Yeah, that's another principle. It might have something to do with the Magnus effect, maybe, but...
Oh yeah, indeed,
yeah?
It's the Magnus effect. Okay. Yeah.
That's basically causing, when you like spin a body around, then you have a certain force exerted on it.
Yeah, it's the way you can spin a ball when you're playing ping pong or tennis or whatever sport you like.
Mm-hmm. I came across this on Reddit today incidentally, where this effect was showed to the extreme. But that's, anyway, we're drifting.
Yeah, about a ping pong table, right?
Yeah.
Yeah, I've seen that one as well.
Oh, nice. But no, this is actually a different effect. The way it works is let me say it like this. The guy that created this concept actually was reminded by the Tacoma Narrows Bridge, and the name might not say or tell you much, but you probably all seen the footage. It's that one bridge that collapsed because of a resonance effect. And you probably know the video where you see like this bridge moving up and down and very violently moving up, and then at some point it breaks.
Yeah, I know that video. I think I've seen it like 20 times already. When you're studying civil engineering, a lot of professors like to show you that movie. Okay,
so you know the principle. It's basically it's physics, and if like the wind flows around the structure, then it can cause resonance within the structure, and at some point the resonance becomes so big that the structure can break.
Yeah, that's exactly what happened. It was a phenomenon called galloping, if I remember correctly, mm-hmm. And the velocity and the period of the wind was quite close to the eigenfrequency of the bridge, which made it break actually.
Yeah, and so you would say that it's not a very favorable thing to use, but if you can control this, then what you can do is actually make a pole like this one vibrate back and forth, and with that vibration, you can again create or convert the mechanical energy to electrical energy.
So it's just resonance, but instead of in a terrible way, you want to use it in a practical way.
Exactly. And when I saw this, I was like, oh, great, nice. So why is this not being used yet? And the big problem with this design is upscaling. Because if you start to upscale this and make the pole bigger, then you also need, if I recall correctly, you need bigger wind speeds to make like the pole vibrate. However, what then the problem is that the spectrum of resonance frequencies of the structure is started to become a spectrum instead of a nice single frequency.
Yeah, right.
Because at smaller scales, it really, you see it vibrate at one frequency, and that's like the one resonance frequency that it works with. But if you upscale it, it becomes a spectrum, and then it becomes less efficient.
Yeah, also you have to match the spectrum of the velocity of the wind with the spectrum of the natural frequency of the turbine you'll have.
Yeah, or at least of the, like, yeah, I'm not sure if it's spring loaded or anything, but of course it like needs to vibrate back and forth. But indeed, that is the problem with upscaling it. It's probably never ever gonna work on a bigger scale.
But the question is then, how much energy does a conceptual design like they do over here generate?
So they did make one, or at least they made a concept design. They actually like worked that one out, and if I recall correctly, it's like it's not a lot. It's like 100 kilowatts or so.
100 kilowatts.
Yeah,
okay.
So it's like not that much, and they made a wild promise of upscaling it in the future, but that's probably not going to happen because of the reasons we talked about.
I was scrolling to the article you sent me, and it says 100 watts.
Oh yeah, indeed. Yeah, so I was horribly mistaken here. I had
a factor of 1,000. 100 watt is like nothing.
Yeah,
that's not a really well developed design then.
Mm-hmm. But still, when I saw this at first, it sounded like a really nice thing. But yeah, at second thought, it's not as great as it sounds.
Yeah, you're right about that. It looks great. It's a fun fact that it works, but if it's really that useful, I don't think so.
Yes, indeed. So whether you will harvest your wind power with kites or with wind turbines in the future, one thing is for sure, there will be more than enough energy left to visit our website.
Are you trying to make nice segues again?
I'm maybe forcing it a bit, but oh well.
Am I ruining your segue?
No, not at all, because we still have enough energy left, even after you ruined everything.
Okay, great.
No, but yeah. So where can people find us?
ageoftechpodcast.com. That's our main source, of course.
Yes.
And iTunes. That's the second one. Mm-hmm. And you know where to find us, I guess.
Yeah, so YouTube is still up as well. However, we encountered a small problem with SoundCloud.
Yes, we did. And that's a massive problem at the moment, but we are gonna fix that. Yes. We just can't promise that SoundCloud will still be up after this episode launches.
So yeah, with that in mind, thank you all for listening, and hopefully see you on the next one.
Adios.